Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, grade 10s and 11s and 12s, this video is on laws of exponents. Please note that the laws of exponents topic starts in grade 9 when you're introduced to it, but you're going to need it all throughout high school. Maths builds up, so you need to be very confident with your laws of exponents. Let's get right into it. The very first law of exponents that you guys have to know is that if you have the same base multiplying one another, you keep one base and add the exponents together. For example, if you had a to the m times a to the n, that's the same base a. So you keep one base of a and then you add the two exponents m and n together. This is what you do. So in other words, if you were to have x squared times x to the 3, that's the same base of x. I would keep 1x and add 2 plus 3 together, the exponents, to get 5. If you had t squared times t to the 5, that's the same base t. Keep one base and add the exponents, so you have t to the 7. If you had x squared, y to the 4 times x cubed, y to the 7, the x's here, that's the same base of x. So you keep one x and you add together the exponents 2 plus 3 to give you 5. Keep the y, add together 4 plus 7 to give you 11. If you had 3x squared y cubed times negative 5xy squared, well, 3 times 5, 3 times negative 5 is negative 15. But what's x squared times x? Remember, x has a silent 1, so this is the same base multiplying one another. So you keep one base, you add the exponents 2 plus 1 to give you 3. This now y to the 5. If you had negative 2x squared y cubed times 4y squared, that would be negative 8x squared and y to the 5. The rule is if you have the same base multiplying one another, keep one base, add the exponents. In a very similar way, if you have the same base dividing one another, then keep one base and subtract the second exponent from the first one. So a to the m divided by a to the n, you'd keep a, then you'd have m minus n as the new exponent. For example, if we had x to the 5 divided by x squared, this would be x to the power of 5 minus 2, which is 3. If we had 60b to the 7 divided by 15b squared, well, 60 divided by 15, those are numbers. 60 divided by 15 is 4. But b to the 7 divided by b squared, these are variables. When we divide variables, we keep, if they have the same base, you keep one base, you subtract the second exponent from the first one. 7 minus 2 is 5. I want you to note that this rule allows us to cancel out fractions. So what I mean is, you might have seen that we're allowed, when we have a question like this, we're allowed to cancel this x with one of the x's in here, leaving us with x squared. This y squared can cancel two of the y's in there, leaving us with y to the 3. And so this is now x squared y to the 3. The reason we can do that is because essentially we have x to the power of 3 divided by x, right? Which means we keep one base, x, and we take that 3 minus the 1, leaving us with 2. So the reason we can cancel out when we have fractions like that is because of this rule. Similarly, if we had 25x to the 5 over y cubed times y to the 7 over 5x squared, then this y to the 3 would cancel 3 of the y's in there, leaving us with y to the 4. This x squared would cancel 2 of the y's in there, leaving us with x to the 3. Now, 25 and 5 divided by one another, 5 into 5 is 1, 5 into 25 is 5. So what you're actually left with here is 5, x to the 3, and y to the 4. So these are the first two laws that you have to know. Now, the third law has to do with what happens if we raise to two exponents instead of one. So for example, if you had a to the power of m and then raised that to the power of n, what you have to do is multiply those two exponents together. So for example, if you have x squared raised to the 3, that's x to the 2 times 3, which is 6. If you have y to the 4 raised to the 5, that's y to the 20. Now, another law tells us that if you have two different bases multiplying one another and both of them were raised to the same exponent, then you need to distribute that exponent to both the bases. So a times b all raised to the power of m is a to the m times b to the m. So if you have xy squared, that's x squared y squared. But what happens when you have a situation like this? These already had exponents, and all of this is raised to yet another exponent. Well, then you need to put together these two laws. One of the laws says if you're raising twice, then you multiply those two exponents. The other law says if you're raising to two different bases that are multiplying one another, then you must distribute that exponent to each of those bases. So if we have x to the 3, y to the 4 raised to the 3, then the answer would be x to the power of 3 times 3, which is 9, and y to the power of 4 times 3, which is 12. If you had 3c cubed d to the 5 all squared, well, 3 to the power of 2 is 9. C to the power of 3 raised to 2 again is c to the power of 6. D to the 5 raised to 2 is d to the 10. Here's one more example. If we had this question, then we would first, again, distribute this 3 to every single one of those bases. 2 to the power of 3 is 8. But if you're raising x squared to 3, then you must multiply the 2 with the 3. So this is x to the 6. This is y to the 12. Multiplied by 3 to the power of 3 is 27. And x to the 3 and y to the 9. Now, 8 times 27, according to my calculator, is 216. Now, what about the fact that now we have x to the 6 times x to the 3? Well, the very first law we learned said when you're multiplying the same base, you keep one base, and you add the two exponents, 6 plus 3 to give you 9. Then y to the power of 21. I hope these are making sense. Another law, very similar to the previous one, tells us that if you have two different bases dividing one another and you raised both of them to the same exponent, you should again distribute that exponent to both the bases. So a over b raised to the power of m is the same as a to the m over b to the m. So if you had x over y raised to the 3, that's the same as x to the 3 over y to the 3. Putting it together with the law that has to do with raising exponents twice, this 5 must multiply the 2 and also multiply the 5. So the answer here is x to the power of 10 over y to the power of 25. In this question, well, 2 squared, that's 4. X to the 3 raised to the 2, that's x to the 6. We must raise it down to the denominator as well. 4 squared, that's 16. Y to the 5 raised to the 2, that's y to the 10. Great. The last law that you have to know is that any number raised to the power of 0 gives us 1 as the answer. A to the power of 0 is 1. 3 to the power of 0 is 1. You can even try check that on your calculator. You'll find 1. X squared to the power of 0, 1. What about 3 million to the power of 0? 1. Any number raised to the power of 0 is 1. These are all the laws of exponents that you need to know. But I want us to also talk about negative exponents. Now, I know a lot of you get quite confused when it comes to negative exponents, and I would really like to help you. First of all, we don't like negative exponents. Goodness, mathematicians hate negative exponents. I don't know where the beef started, but mathematicians and negative exponents have some Kendrick and Drake thing going on. Okay, so that's the first thing I want you to know. Now, because we don't like them, there's a way we remedy this that is mathematically correct. And that is, whenever a variable has a negative exponent, move it down the division line and ensure that you then change the sign of the exponent to a positive one after you have moved it. Now, you'll see what I mean by that in just a second. Here's an example. If you have x to the power of negative 2, remember, this is the same as having x to the power of negative 2 over 1, right? What we're going to do is we're going to move this entire variable down to the denominator. We are allowed to do that as long as we change the sign of the exponent. So then this becomes 1 over x to the power of positive 2. Here's another example. If you have y to the power of minus 3, would move that y down to the denominator to become y to the power of positive 3. If you had 3 over x to the power of negative 4, you would then move this x to the negative 4 up to the numerator. You can do that, but you just have to make sure that you change it to now have a positive exponent. If we had something like x to the power of negative 3 over y to the power of negative 5, we have to move this x to the power of negative 3 down to the denominator. It will become x to the power of positive 3. Then move this y to the negative 5 up to the numerator. It would become y to the power of positive 5. And so the answer to this is y to the 5 over x to the power of 3. So I hope this statement is starting to make a little bit more sense. Whenever a variable has a negative exponent, move it up or down the division line and ensure to change the sign of the exponent after you move it. If you have 3 to the negative 2, and I want you guys to check this with your calculator to show you that it's actually correct. See, if you have 3 to the negative 2, that's the same as 1 over 3 to the positive 2, which is 1 over 9. Go ahead and put this in your calculator. You will get 1 over 9. 5 to the negative 3 is 1 over 5 to the positive 3. And 5 to the positive 3 is 125. So the answer to 5 to the power of negative 3 is 1 over 125. This is how negative exponents work. We don't like them, so we always move a variable that has one either up or down the division line and then change the sign of its exponent. Now, please take note, this has nothing to do with the sign of the variable itself, just the sign of the exponent. What do I mean by that? Well, if you had, say, negative x to the power of negative 2, okay? Or let's say negative 3. This is 1 over negative x to the power of, or maybe if it was in brackets, then negative x to the power of positive 3. So it has nothing to do with the sign of the variable, just the sign of the exponent. When you move something either up or down the division line, you must change the sign of its exponent. Not the sign of the variable, just the exponent. Here's an example. If we add x to the 3, y to the 4 raised to the negative 2, we know from laws of exponents that this is now x to the power of negative 6 and y to the power of negative 8. This is then 1 over x to the positive 6 and y to the positive 8. If you had x over y to the negative 1, what do you think the answer would be? Well, we know that this negative 1 must be distributed to both those bases, right? So you could say this is x to the negative 1 over y to the negative 1. But then, because we don't like negative exponents, the y would come up and have a positive 1 as an exponent. The x would go down and have a positive 1 as an exponent. But again, we don't write that 1. It's silent, right? Some people, the minute they see something like a bracket raised to the negative 1, they just go ahead and say, oh, well, that's just y over x. Which makes sense, doesn't it? Because we can just flip them around and change the sign of the exponent. We know that this is going to be negative 1. And when we move it up, positive 1. Now, let's look at some practice questions together. Some of these will get a bit tricky, and I actually suggest that before you watch me do it, pause the video and try it out yourself, and then compare with what I have. Remember, most of the learning that you do in maths happens in practice. Here's what we're going to say here. This is now x to the power of 10 and y to the power of 15 multiplied by x to the power of negative 3 and y to the power of negative 6. This is now x to the power of, now there's multiple ways you could do this, but before you get to the final answer, it's okay to have negative exponents. Maybe I forgot to mention that. We just don't want to see them in the answer. In your working, you can work using them, that's fine. But when you get to your answer, we should never see negative. Like I said, we hate them so much, right? So now, this is now 10 plus negative 3. 10 plus negative 3, because we have the same base multiplying one another. And that's just 10 minus 3, which is 7. Now this is y to the power of 15 plus negative 6, which is y to the power of 15 minus 6. So y to the power of 9. This would be the final answer. Let's look at B. Feel free to give it a try first and then see if you get the correct answer. Well, in the numerator, we now have a to the power of 5 and b to the power of 7. In the denominator, we now have a to the power of 6 and b to the power of 6. Now, a to the 5 can cancel 5 of the a's in there, and I'm left with a to the 1. Then b to the 6 can cancel 6 of the b's in there, and left with b to the power of 1. So the answer to this is now just b to the power of 1 over a to the power of 1. Great. More examples. This you can go ahead and try. I know it looks long. Go ahead and try, apply your algebra, see if you're going to get to the same answer as me. There's a lot going on, but let's attack it piece by piece. So firstly, this is now x to the negative 1, y to the negative 1, z to the negative 2, all divided by x squared and y to the negative 1. Divided by x to the power of negative 3, y to the power of negative 2, times by just 1. Remember, any number to the power of 0 is 1. Or divided by x to the power of negative 4, y to the power of negative 2, and z to the power of negative 3. What I'm doing there is I'm distributing this negative 1 to both the numerator and the denominator according to one of the laws that we've learned. This is now multiplied by, and I'll just copy this one out, x, y squared, z to the 4, x to the minus 3, y squared, z to the 0 is just 1. Now, before we do tip and times by this, okay, let's perhaps get rid of any negative exponents we have. Okay, so firstly, I think I can just cancel out this. Those cancel away. Okay, now I have this z to the negative 2 and this x to the minus 1. These need to go down to the denominator, hey? I'm left with just 1 up here. In my denominator, I have that x squared times this x moved down to become positive 1. And this z moved down to become z squared. And this is now divided by, again, let's move the x to the minus 3 and the y to the minus 2 down. And then let's also move, actually, the x to the 4 up. Okay, so now we have x to the positive 4, y to the positive 2, z to the positive 3. I've moved these three guys up to the numerator and changed the sign of their exponents. Then I'll move x to the minus 3 down to be x to the positive 3 and y to the minus 2 down to be y to the positive 2. Now on this side, I'll have x times by x to the positive 3. I've moved this guy up. And in my denominator, I actually also have z to the 4 there. And in my denominator, I'm just left with 1 because I've moved this guy up. And oh, no, I'm not left with 1. I should have y squared down there. There we are, y squared. So x to the 3, z to the 4 over y squared. I'm also forgetting this y squared that's in the numerator, hey? Yeah. There's a y squared in the numerator. But you know what? Let's actually, before we do this part, cancel these guys out. There we go. And now we have x times x to the positive 3, z to the 4, and no denominator. Great. Now, before we again start tipping and timesing and all of that, let's fix what's happening here. For example, x squared times x to the 1, that should be x to the 3, right? We know that when we're multiplying the same base, we add the exponents. Divided by, now, this x to the 3 cancels 3 of those, and you're left with x to the 1. This y squared also cancels that y squared. Divided by, now, just x and z to the 3. This becomes x to the 4. Now, grade 10s, 11s, and 12s, please note that we love a mess in maths. Don't try to make everything look neat here. We want to see all this cancelling out. We love a mess in maths, okay? Now, I have 1 over x to the 3, z to the 2, divided by x and z to the 3, times by x to the 4 and z to the 4. Okay, great. Now, this is now 1 over x to the 3, z to the 2, multiplied by 1 over x and z to the 3. This is now x and z to the 3 over 1, and when we tip in times, it's now 1 over x, z to the 3, multiplied by x to the 4 and z to the 4. Great. Let's cancel some things out. Or maybe, let's do some multiplying first. This is now x to the 4, z to the 4, all divided by x to the 4, z to the 5, okay? And this and that cancel. Z to the 4 leaves us with just z in the denominator, 1 over z. Okay, let me know if you also got the same answer or if you think may have made a mistake somewhere. Okay, but this is how you deal with exponents. Now, the power is now in your hands. That's actually a pun. Power is actually how we talk about exponents sometimes, to the power of. So the power is now in your hands. Do more practice, okay? I made this video just to empower you to understand anything that may have been confusing you. Go ahead and do lots more practice on exponents because they can get quite tricky, long, and need a lot of attention. See you in the next one.